Hello, 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 it's Progs. We'll be starting right now. Let me just check the audio, the volume. One, two, yeah, I guess this is fine this way. Maybe even a little, not enough. I don't know. That should be good like that. So anyway, here we go. 4, 4, 4, 4. The exercise we want. Hello. So last my tongue. Last time we were doing the day 8, but actually there was a little problem because it only works on, well, basically we only have to consider the first 1000 pairs and not all of the pairs. And in the example, it was just I actually don't remember. Because basically it was not in bold, and basically there was a lot of stuff that wasn't really explicited correctly. Well, in a good way, let's say. What was it? After making the 10 shortest connections. So yeah, and we only have to do the 1000 pairs of closest connections, right? Which are closest together. So I have to do something about it, right? So I mean, there are multiple ways to do things, right? But for now, let's just discard what I tried doing during yesterday. So we have day 8-1. Yeah, I know, I have really good naming senses. That's fine. Let me change. Okay. So we have this. We have lines, and we return something at the end, which is what is it? This is the product of the three highest things. Or the size of the three highest, biggest groups, right? So now I have the lines. So I guess I'm just going to do the same, and I'm just going to parse. That isn't going to change. So I can just do a parse input, I suppose. And I return a list of points from the contents. Here we go. We have to split the lines, so here we go. And now we just, boom, call that, and that's it. And now we can just basically do the same on this one. So we reuse the code, so this is fine. I don't know, wait. I really don't know, wait. It's always... Anyways. It's not good, wait. Wait, let me check. Oh, yes. Okay, this should be fine. Okay. So, now, you have the amount of points. Yeah, basically the goal is to have all the connections, let's say. It's not really that, but yeah, we can... Actually, let's make a class connection, maybe? Yeah, we have to make a class connection. That is going to be P1, that is a point, and P2, which is a point too. And this is just a list of points, of connections, I mean. Actually, I could even... Yeah, never mind. This is a list of connections. This is fine. And now, basically, the thing is, if I want to make connections, then I guess this is quite simple. Let's say unique connections. So I have for I in range on the points, for j in range, which starts at I plus 1. Now I'm going to push. So append a new connection that is going to be a new connection, well, just connection in Python. We have P1 equals... Actually, we don't even... Because the points are fixed, right? So that means instead of storing a point, I guess in this case a point is a class, so it's like a reference, right? So it shouldn't be like very costly, but we can also store an ID basically. We can store an ID. Let me think. I mean, maybe I just want, you know, like this, a tuple. Because I guess a tuple is a string, so it may be more optimized too. So let's say we have... Wait, this is point though. This is really a point, and this one is just int. Then we basically just do append I and j, and this should be good. That should be good. That should be all, basically. You have some connections. Well, we have connections that are unique, which is important. Let me just think a second, because now basically there's another problem. Not a problem. But we have to test the distances, right? So I guess in a perfect world, we could basically just sort everything by distances, and that would be it. But that's not really what I want. I mean, we don't even have the distance right now, but we can compute it, right? For each connection. And then after that, we can like sort the thing. So let me think a second. We have each unique connection. I mean, we can compute the distance, we can sort it. But what did I want to do on top of that? I don't know. I don't know. I mean, I guess we can... Oh yeah. I only want to add the connection that is the shortest for each point. That's what I wanted to do. So I guess we can have a priority queue too, but I mean, I guess that's fine, right? So yeah, what we are going to do instead is... So we have the square distance between this and this. Then I guess we can actually just put it in the array. Maybe we just put a lot of things in the array, then we sort, and then this is fine. I guess we can. I guess we can do that, right? I'm not really like that, but I guess this is fine. And after that, to detect if it's like the same group, we're just going to use no. We're just going to use this, the disjoint union set. We might even make a new class actually for it. Okay, that was really loud. I'm sorry about that. I hope it's a bit better. Actually, let's go to this one. Okay, you don't hear anything now. One, two. Okay, this is fine. I hope this is fine, yeah. Just tell me if... Wait, actually, I'm just going to listen. 2 seconds. Okay, you don't hear anything now. Okay, this should be fine. Because I guess I don't want to compute the square inside the list, right? I mean, okay, we can do that. Now we just have to sort. And in Python, so you have lambda top, top, top. And I return top 2 to compare it, I suppose. Okay, should be good. And now that it is sorted, yeah, okay, okay, no. Yeah, I know. The problem is that for the same... Wait. So I want to find the closest connection for each point, right? The problem right now is that I'm adding every time, which is not good. So... I mean, maybe I'm just going to start at 0, actually. Am I? I guess I didn't want to sort the distance before. I mean, I could remove that, but do I want to? Do I want to? I guess... Let me think. Unique connection. I guess... Wait, what is the problem again? Maybe the distance should be linked to only one point at a time. Because this is the shortest distance for one point first, right? So I mean, I could technically make a hash map too, but do I want to? No, I don't. So the shortest distance for this point, this is alright. Then we have shortest for the next point. Yeah, let's actually have something very similar to what we had before. I mean, I'm just going to copy at this point. Wait, I'm really just going to copy actually. Let's square this. This is fine. I'm not going to copy directly everything, but first we have this, then we have closest point. Well, point to closest point, let's say. Like, yeah. This is a list of ints. Here we go. And yeah, I guess of course it's going to be less than this, so it's going to override the value. So we have, for the current I, we have the square distance, the current one. Because I is always less than j, so that's fine. Is it? No, it's not. Square list, okay. If we have this I, well, is if square closest square diff dist is less than this, then I have, well, then I just update, right? And then I just set the point to closest point, which is from I to j, because the closest point, the closest point for I is j. And then I guess we can just do the same for the other one. So if the closest square distance is less than this, actually, is it the same? Yeah. Here we go. This is better like that. So yeah, we can just compare it like that. Oh, there is some problem. Okay. And in this case, we have j that is going to be updated to I and the new closest distance. Should be 5. Okay, good. So I guess I can even remove that, right? Because now the connections are just, basically we have to go through every point and we just have to check the one it's connected to, right? The one it's pointing to. And that should be fine. Well, I guess we still have to sort them, right? Which is a bit of a problem with this structure. With the square distance. Point to closest point. I mean, yeah, it would be like easier to have a class connection, actually, in this case. A lot easier. That's a bit sad, but yeah. But we can also try to do some trickery, maybe. I guess we can have... Okay, I have an idea. I have an idea. I have an idea. But then I wouldn't know what point corresponds to each point anymore. Would I? Wait. Actually, I would. Okay, let's just have... Okay, that's going to be maybe a bit weird, but... We're going to have a sorted... well, points, let's say. That is going to be a list. That is going to be... Actually, I can just do... Crazy, I can just do a range, okay? From, well, until NV points. That should be fine. So this is basically from 0 to, you know, the last number. And what I'm going to do is I'm going to sort that. So yeah, let's say bye-bye to unique connections. I'm going to sort this. And how are you going to tell me? Well, this is simply an index, right? Well, I'm just going to use this index to get the closest square distance. And now it should sort by the closest square distance, right? Like from the shortest to the one the furthest away. So it should be fine. Can I have a limit? Because in Python, in C++, there is something called CPP sort. I don't remember the name. It's n. It's nth element. We have that in C++. That is sorting only the first elements, the first few elements. Wait. Yeah. Wait. Edit 2. NumPy partition. We create 2 new array. Wait. We can make a lot of new arrays. Oh no. Oh no. It's supposed to be worse. Oh no. Math. It looks like nice, right? But huh? Below, above. So okay, it's actually just a tutorial. Okay. I don't really like it though, but okay. I mean that's fine. So yeah, we sort our points, and then what was the thing? Yeah, we just have to get the for the like 1000 first elements, right? So wait, which one was it? there. It actually closed the advent of code. Oh no. Here we go. So yeah, actually... I mean, there's a pivot. Let's just sort everything and let's make a to-do nth element. So we have this. Now we're going to go through the range, like the first 1,000 ones, maybe, like the, what was it? "11 circuits, 10 shortest." So for the, well, NV iterations, this is going to be 10. And we also are going to have 1,000. Okay. And then we just have basically to... Basically that's our queue, right? That's this thing. So... what can we do with that? I guess we can just spawn it. And do the same as we did before. For each group, we add +1. And then we multiply. I mean, yeah, it looks good to me. So for every iteration, we only add to the group if we... okay. For I in range. Okay. So then we have like p index equal sorted point I, right? Hello, Solaris. I'm struggling on day 9, harder than day 8 in my opinion. Oh, yeah, I've been struggling a little bit on day 8 yesterday, but I guess it was like very late and I didn't understand the thing correctly, so I think I had a lot of problems because of that. But right now I'm kind of handling it alright. Just taking some time, right? But yeah, I haven't seen day 9 yet, so let's check that afterwards. I guess I'm still on part 1 for this one. Priority queue, let me think. Do I really need that? So wait, yeah, I do. Because this is only for the 3 elements that are the 3 largest circuits. So yeah, this is fine. My priority queue is fine. I can just create it again. Yeah, I can just reuse a lot of stuff I did, which is great. Group to size, yeah, I'm still missing that. Then I have the get group and group to size, okay. So let's get the... Actually... let's... Day 8 is a known problem called Euclidean minimum spanning tree. It's solved by an algorithm called Kruskal's algorithm. So I didn't struggle that much because I had already solved it many times before. I don't know if I Maybe I solved it, but let me search that. But I do like the disjoint union set, but I think it's taking more memory. Even spanning forest. To sort the graph edges by weight. So yeah, okay, that's kind of what I'm doing. Move through the edges of the graph in ascending order by the weight. That's what I'm doing. For each edge, test whether adding the edge to the current forest would create a cycle. If not, add the edge to the forest, combining two trees into a single tree. Yeah. Wait, what? Yeah, I mean, it's fine if it creates a cycle, though, because no, this is about a tree. This is trying to prevent a loop, but we don't mind loops in our code. We don't mind loops in our code. So this is actually wrong for our case. Right? Wait, actually, is it? Wait, ow! Because there's like the... Wait. I mean, it actually... Yeah, I guess it doesn't matter because in the end they're still in the same circuit, right? Even when not knowing Kriska, a lot of solutions ended up using it by accident in part 1. But well, you still need to maintain the size of each connected component. Yeah. And yeah, basically what I wanted to do was basically that. But the difference, I guess, is instead of checking if this makes a cycle, what I want to do is basically disjoint union set this stuff. Which do we have? Algorithm. Finding set representatives. Merging two sets. Yeah, Wikipedia is not really... Oh. Disjoint. Oh. Disjoint. We create a new. Union. Anyway. Let's see how it goes. So yeah, actually, maybe I should make a disjoint union set data structure, which is going to have the group to size. Oh. Maybe not. It's basically going to have points to group, like I guess ID to group. Yeah, but it's like yes. So let's just put the size, which is going to be size, and we have this. Well, never mind. Wait, content isn't actually used. My bad. Okay, then we have, I guess, union set, which is going to have a size of enemy points. Let me think a little. Okay, yeah, I think this is basically in here that I'm going to update it. So we have this. I have sets group, maybe? Well, a link groups. That should be fine. Like a sets group. Sets group from, and we have the two. So I from, let's say, and I to. And it's just going to do ID to, well, I guess I need the self. Self.id to group, I from, equals I to. Okay. So now I can do a set group here. Closest, yeah, set group. So from I to J, this is the closest. And this is from J to I. I guess we do have a loop in this case. But is it fine? I mean, maybe it is. Who knows? Yeah, I mean, there's going to be a problem actually if we have a loop. Right. Okay, let's... I mean, I guess this is fine. But it should basically be not to I2, but to get head, get group maybe, right? And this is going to return get group of I. The group is ID to group. That's ID to group I. So this is a direct group, right? But then let's do that. But then we have to make a while. So that's while while group is not this, or yeah, I guess this is it. While the group is not pointing to itself, then we update it. Should be good. That way, since we are going to get the group here, the group should always be like unique, I think. Like for example, let's say that I is linked to J, then that means I is going to point to J, and let's say then J is going to point to I. Then we set the group. We call the get group, and we detect that I points towards J, and J points towards J, so it stays in the same group. So this should be good, and there shouldn't be any loop. So actually, it's actually what you said, Solaris. Why do I have this? Wait, what? Group to size. Anyway. Disjoint P index. I guess I want to get the group of the point. So I get the group. And then for everything I just plus one. So we actually have sorted element. I guess I still need this, right? So let's just have this equals 0 times NB points. Then we update. And let's check if this is valid or not. I'm going to have some problems, I feel. Of course. So, yeah, this is actually funny. Content missing. Uh-oh. Uh-oh. Oh, yeah, indeed. What about here? It's not. Okay, the first one is an error, but not the second. None. Oh, none. Here we go. Oh, right, this is the wrong exercise. Let's put this one. Okay, out of range. I mean, because this should be 0, right? Range has... Okay, they got me. They got me. I thought it would be converted to a list, but I guess I have to call something like toList or like lists, maybe. Because this is just an enumeration. So it's like lazily evaluated. Sort takes no positional argument. What? Oh, is this thing again? How is it? I forgot. Lambda index. Okay. Oh, right. Positional. Yeah, because this is actually the sort. Sort. What was it? Key, reverse. What? Sort? Key. Key? Is it... Maybe this is just key. Key equal that. Key? Wait, what did I use before? Did I even use something? Next out of range. Okay, it seems to be good. And out of range. Oh wait, this is funny. Oh yeah, because I haven't pushed anything inside. Right. Wait, actually I did. 10. Ah. I mean, I guess I haven't pushed any individual elements, but actually, never mind. This should be fine. Yeah, should be alright-ish. Let's debug that. Boom. 0. That's a problem. So what about the disjoint union set? What do we have? We have this. Okay, thank you a lot. We have ID to group, which is really bad. So yeah, this is actually not initialized. Why? Set group should be called. Get group. I guess ID to group is 0 from the start. Maybe it's just not updating. I don't know. Let me actually check. Okay, so it's going here. It's going here. I guess I should actually update the group itself. Get group. So this is 0. This is 1. So 1 points to 0. Okay, this is fine. What about this one? 0 points to, let me guess, 0. Wait, 1 points to 0. Wait. Yeah, makes sense. And then 0 should point to 0. Again, because they're in the same group. Okay, then next, we have 2 is 0. I from is 2. What? Interesting. Let me actually calm the music a little. Okay, here we go. Yeah, let's just stay peaceful tonight. I just wanna sleep. Maybe, what's this? Oh, never mind. Okay. Yeah, this one is free. Yeah, this one is like so peaceful. Let's put this one from TAC MFK. Yeah, I've actually listened to this one like so much. Maybe I should. Maybe I don't have the patience for it anymore, but that's fine. Let's input. Yeah. So wait. They should be initialized to themselves, not 0. So maybe let's. Yeah, this is wrong. I need a range size, and I need to convert that to a list. Here we go. Should be better now. A lot better. Let's put a breakpoint. And okay, that means there is a problem in the while, because there is like an infinite loop, right? Group. This 19 And if I do it again, 19. Wait, this is actually good. Oh, yeah, okay, this is the group, my bad. Okay, got it. Yeah, of course it wasn't going to work. Okay. Should be good. Okay, and now we reach the end, which is good. So let's first check, maybe it's working right away, but we have to verify, right? So we have points that are sorted. Okay, why not, by distance. Then we have the group to size. The group to size is definitely not good. But yeah, it's not good. So let's check the disjoint union set. Here we go. We have 19, 3, 7, 19, 19, 19. We have a lot of 19, but that's fine, I suppose. Will be fine. I'm actually not sure whether that's the correct place to use the disjoint union set. Probably not. Because we only have to... Yeah, that's probably not the correct place. We should probably do it here, because we have to only link them together if they are... like, only for the first 10 or the first 1000. So yeah. Yeah. Let's remove that. Let's add it here. Yeah, should be good. Set group of I to, well, J isn't here, right? So that's a problem. But I can just get the points to closest point. And I can get the closest point this way. So I can get J, basically. So I now points to J. So now I get the group. Actually, should I? Should I? Maybe I shouldn't. Maybe I should split that into loops. I mean, it will like be better probably. I'm not sure about this. P index set group. I mean, is it going to change the order? The amount of points, I mean? Probably not. It's not going to change the amount of points in a group. So that should be fine. So each... Oh, right, but it's going to update the groups. Oh, yeah, so it's actually exactly what you said, Solaris. I'm doing exactly what you said. Yeah. I'm doing exactly what you said. I'm realizing. Because I'm going to set the group, but basically I'm just going to go to the first point added to the tree, and this is going to be exactly it. This is going to be exactly it. So I set I to this. Yeah. Then... yeah. I mean, yeah, this is good. This should not change, right? So then I can just get the group of I suppose. Not, never mind. P index. Well, actually, this is not I. This is P index. So then I get the group of the point. Then I increase the size of the group, and yeah, then this is good basically. I add it to the priority queue, and this is it. So let's try again. You have the starting points is correct, probably, maybe not. You have point to closest point, which seems to be alright. We have the disjoint union set that is looking fine. That is looking fine. Like really, really looking fine actually. And this one, 12, 13, 14, 15, 16. This is good. This is basically the IDs. And this is basically because we are not in the first 10 elements, right? Or there, wait. 1, 2, 3, 4, 5, 6. Six? I feel like there's still some kind of problem. What about the priority queue? Boom. Wait, sorted elements. 19, 13, 18. Oh, yes. Oh, yeah, element to size might be fine. Actually, it's not. Oh, no. 19, 13, 18. Okay. Oh yeah, never mind, because this is for the day. Yeah, this is the wrong input. What about? Well, this is actually test input. Wait, this is actually fine. Well, it should be fine. So that means there's a problem, right? Because the result should be like 5, 4, and 2. So yeah, there is a problem. Point to closest point. So everything here should be fine. If I check, for example, I mean I can just check here. Point to closest point. I can verify that. Three junction boxes. 15 circuits. Closest together, but are not already directly connected. Okay. Wait. 162.817. So this is the first one with 0, 1, 2, 3, 4, 5, 6, 7. Yeah. So let's check if 0 and 7 are connected. 0 and 7. Okay. The 7 is connected to 0. So this is actually good. This is actually good. Wait, so yeah, it actually works kind of fine. It seems like. Points to closest point. Maybe I should have like some kind of like maybe I should try it the naive way. Yeah, let's actually do that. Find closest naive. So I have the amount of points, let's say. I have the points. So, I mean, I guess I don't need actually that. And just do this. And closest square distance. I mean, let's just say that for each number, if I is not j, but if this is equal, we continue. And else points to closest point. I think I'm just going to return an array actually. Points to closest point. I'm going to return this. And this is if square distance is less than the square distance for the, I guess, closest. I mean, I can just set that to the max, right? I actually don't need that array for long. Well, in this case, I don't. Okay, it should be good. I said I to j, and yeah. And now I should have closest square distances. So this is naive equal points, and that should be it. And now I just have to ensure that for I in NB points, basically, I check when I assert that this is equal to basically the same but without the naive. And this should be it. Is it going to find oh, what? Oh, yeah, my bad. Hahaha, they got me. Yeah, I thought that in whatever language it was possible. I think it's GDScript. 12. So it's not crashing. So this is correct. This is basically correct. This is correct and this is good. And points to closest point, closest square distance. So yeah, this is actually semi-opti, let's say. Well, it's optimized without how do you call that? A special partitioning. Opti without special partitioning. This is a really long name, but this is fine. What I want is basically to encapsulate this into something like this, maybe like this. Now we have closest square distance. Because this is temporary, I actually don't need to keep that. Oh no, myself. Oh no, myself. Okay, not myself anymore. Okay, so find closest. Yeah, and this one should be good, and we discard the memory at the end of the squared length, which is not bad. So then instead of all of that, I'm just going to have points, and it's going to be points to closest point. Here we go. So now I can remove this. I can remove this, and this is great, and I can move it to, well, down basically. Sorted points. Yeah, let's do this. Actually, it's not needed. Oh wait, actually, closest distance, I need that. I need the closest square distance. Oh no. Oh no. Yeah, this is fine. So then I have this. So this is fine. For the disjoint union set, this is here. I'm going to put it here. Okay. What? So I mean, yeah, this is good. What was it? I guess, how do you check if two lists are equal? By deep comparison. Yeah. I mean, I guess this is fine, right? I basically don't really want the loop, but I guess this is fine. So this is correct, which is great. Then I have the sort, which is, I mean, obviously correct. Probably. I hope. So from 0 to NB points. Sorry. Yeah, this is good. Is it because of that? Wait. I guess my disjoint union set might not be, but it's not looping forever. So I mean, there's no, like, it's not really complicated to have something working with this. Like, there's not like a lot of stuff to do. So what is the problem with this? Group to size. Maybe it's this. Maybe I'm not getting the head of the group right away. But at the same time, never mind, because I'm putting the first point. Okay, let's simulate that. I'm putting the first point. Okay. So I have the first point. I put it on the graph. So I set the group to... Oh. Uh-oh. Okay, maybe I get it now. Wait. I guess I should point it to itself. But wait, no, in the first case we already have. Wait, what? Yeah, we don't have anything actually at first. It's just pointing to itself at first. So let's say you have... Wait. You have a point. I do have a point. Then I'm getting the point that is closest to that first point. And I'm saying that this is the parent. But this point is not placed yet. So what happens if when I put this point, this new point, this is linked to another one? Then that means it's not going to be correct. Okay. This is not going to be correct. So yeah, maybe I do need to split the functions actually. I do need to split all of that. Like basically I set the group for every point in the iteration. And then I'm going to on again to get the group, because now the tree should be formed. And then I just increase the size, I just push, and it should be good this time. I wasn't sure at first if I needed to split the loops or not, but I guess it's for the best. But now there's a crash, so let's see what it is due to, what's the reason for that. We shouldn't be too complicated with all of our debugging power. So, okay, ID to group. We should have 10 elements that are not pointing to themselves, or like 9 actually. So 1, 2, 5, 6, 3, 4, 5. So we only have 5 elements that are not pointing to themselves, which is kind of a problem, I believe. Or is it? 5, let's say that there are... I actually don't know. But yeah, I mean, this is actually a problem, kind of, because the get group isn't actually very accurate, because now I can just update it to the new group, right? Makes sense. So if I do that, is it going to update things correctly? Well, even more correctly, let's say. Out of range. So yeah, I guess this is a problem. There is only one element and it's 16. So let's check the union again. One, 2, 3, 4, 5, 6. And this is it, I guess. 6. 6 plus 3 plus 1. Maybe this is enough, I don't know. What about... Okay, what about group to size? Okay, this one definitely has a problem. This one definitely has a problem. Okay. Okay, yeah. So I guess this is 0 at first. And it does +1 to the group. Wait, what? So everything is just going to the same. Every element is in the same group? But I have more than 10 elements, right? This is crazy. Let me think a bit more. But I guess basically after ND iterations, every index should be bound to themselves. I guess that's just one. I'm just thinking about the priority queue, like in case there are not 3 elements, 3 different groups. But there should be, right? So that should be fine. So yeah, group 2 size is definitely not working. Definitely not. How to... So let's say I set the group. Okay. Oh wait, I know. This is because I'm not setting this again. Yeah, okay, this is a problem with variables in Python. You just don't know when it's going out of scope. This is so bad. So now it's 12? What? I mean, it's a lot better, right? Before it was... Well, it is supposed to be 20. So let's check the group to size. Okay, this is actually quite alright. But the groups are wrong. This is the problem. The groups are wrong. 2, 2. I guess everything should be 1 by default. So wait, what if it's linked to itself? What if it's linked to itself? I guess we can have 1. Oh. 1. And if basically if group is not p index, if it's not pointing to itself, then we continue. Is it correct? Is it right? Maybe it is. Let's check. It feels like I had too little and I'm making it even more little, which isn't good. But now I have ones everywhere. I have the 2, 2, I have the 2, 2, 3. So I guess this is actually kind of what I had before, but with the correct numbers for the base elements, which is kind of great, which is kind of neat. But yeah, it's still not good. So let's just count everything now. Well, basically 2, 3, 4, 5, and 6. So we only have 6 elements that are going inside this loop instead of 10. I mean, I guess that's fine, because if there are 3... I don't know. I mean, some elements are going to go to themselves, right? So that makes sense that not all of the 10 elements are going to, you know, increase. Actually... Wait, actually this is a problem. Because some elements should be 0. Wait, some elements should be 0. Why isn't it the case? I guess group to size. I guess if this is equal, then I minus 1. Something like that. Well, actually. If this is pointing to something different, then we minus 1. That way it comes to 0. Okay, this should actually be good. And now we have to count if this is... So this is to debug. This is actually not going to be used, I think. Or maybe actually. Anyway. Whoa, that's a lot different. So wait. How many elements do we have? 20. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20. So we actually conserve the correct amount of elements, and this is actually the correct amount per connection, you could say. But the problem is that this actually doesn't seem to work correctly. So 19 is the biggest one, which is correct. And then you have 1. Well, no, actually we have 13, which is maybe 2, which is correct. And then we have 18, which is 2, 2. So that's kind of correct. So the queue is working, the group to size is working. So that only means one thing. The problem is in the disjoint union set. The problem is in the disjoint union set. There. And gets group. Yeah, I mean, it's supposed to be good. If then I go to the parents, then I update the cache. Okay. And when I set group, I just do this. I mean, I don't even need to get the group, probably. Actually. I mean, actually, I'm going to just get group later, so I don't even need to set like this. Yeah. I can just lazily set it. So I set it to I2. And then I get the group later, so it's going to update everything. Update the cache too. So is it actually leading to something different? It shouldn't, but is it? Or is it going to lead to... Yeah, okay, it's an infinite loop, that makes sense. Because now it's like 2 elements are bound to each other, probably. And it's not going to end well. So let's prevent that and let's keep this get group, actually. Yeah, this was fine. Let me just remove it and like reset it for good. Sorted elements. So yeah, the disjoint union set. Am I using maybe the wrong variables? So I initialize with the amount of points. ID to group. So every point is pointing to itself. Then for every point, sorted by distance. Well, basically it's a connection. So for every connection starting with the shortest, what do? I'm going to loop. I retrieve the connection, you could say. Here I retrieve the connection. I set the group from one point to another point. And this is correct. So this should be the closest point to this one. Okay, so then the second one, if they are linked together, then it stays on the same node. This is good. I don't really understand where it's going wrong with the disjoint set. Maybe it's not the disjoint set. Maybe I'm just using a wrong variable somewhere. Get group, p-index, but I don't see it. So yeah, let's have that. Let's have... Okay, so sorted elements. I mean, sorted elements is fine. We just verified it. So let's just compare this with group to size. (19). 19. So we have 3 elements pointing to 19. So this is logic. Group to size is correct. What about 18? 19, I mean. Oh wait, no, 18. 18, 1, 2. So this is correct. 17, we have 0 elements. This is correct. 16, we have 1, 2. Correct. Yeah, okay. Group to size is correct. Wait, group to size is correct. Group to size is correct. (13), 2. Yeah, nothing is pointing to 2. 3, there's 3. All of that, there's 1. 19, so that's 0. I mean, yeah, this is correct. Group to size is actually correct. If we check ID to group. So something is wrong in the ID to group. And (11 circuits). Two circuits, 2 junction boxes. I'm actually kind of stuck. I mean, I guess I could deny. I can. What can I do to debug that? I mean, I guess I could print, right? I guess I could. I mean, the best way would be to visualize it. Can I actually do that in Python very easily? I think I could use peel to create a window. Okay, we can actually try that. Draw tree. Well, draw 3D points and connect. 3D scatter plot. Oh, right, it's in 3D. Yeah. Matplotlib. Ah, light. I mean, I guess I could do something like that. So import matplotlib. Yeah. By plots as plot, I suppose. Yeah. PLT. Doesn't matter, but Ray 8. Let's create set group. Let's create here, maybe, a figure. Then let's add a subplot. I figured out. Add subplot. What's this thing? Maybe I have columns. Oh, columns. Position. Axis. So I guess if I just put an int, it's going to be pause, right? Okay. Let's just put projection equal 3D. Axis. I guess basically it's putting 1, 1, 1, but I don't really know. Yeah. For integrals, subplot will take the index position on your grid with n rows and n columns. So a 3-digit number, the digits are interpreted as if given separately. Okay, so this is basically the equivalent of 111. So okay, get it. Yeah, so I can put like instead of 100. Yeah, let me just put 111. I prefer that. Then we have points. We have the axis dot scatter our points. Okay. Equal. Color is red. Okay, it's going to be O. And then at the end we have to plot, if I remember correctly. So this is plt.plot. The figure? I just figure out plots, I suppose. Wait. plt.show. Oh. This is at the end. But then we have plot 3 points and lines. Axis.plot. I'm not sure about that. What if I put like 0, 0, 0? And I show. I mean, I feel like it's not going to do anything much. What is this? I mean, points is not really what I want to but actually, yeah, this is really bad of what I did. But I don't want to create more arrays. I don't want to create more arrays. Stop. So scatter and plot. I mean, I guess I don't need one. Yeah, I guess plot is for lines and scatter is for points, right? So can I... Oh, actually, there's something in NumPy. But I forgot what it is. But to splits... Yeah, but I guess it's like I have objects, right? So that's a bit different. Maybe I can just have x equal points. Well, for p in points, p dot... Wait, isn't that how you do in Python? Oh yeah, right, for p in points. So this is at the end, and I just do... Yeah, let me check. Python, same line loop. Python for same line. One line. Okay, these comprehensions. So yeah, this is actually, I have to add this. Here we go. And for, okay, so this should actually be fine. And now this is x. Okay, good. Oh, I was close. This was basically just the array kind of thing. The y and z. Then I have x, y, and z, right? I believe. Yeah. Let's try. Okay, plot me. Boo. Here we go. Okay, this is great. We have a plot. That was fast. Okay, now I want to show the lines. Now it's going to get interesting. So the lines, that's dot plot. So axis dot plot. And every line, wait, what? Oh, right, I don't want to show a line, I want to show segments. Peel, draw, segments. Really segments. Camera distance. Wait. I don't think that's what I want. Plot. Pretty lines. Plot XYZ. But I feel like this is going to be a line, right? I want a segment. Yeah, I typed line. I shouldn't have. Ooh. Hello? Oh. What? Image? Oh no, this is an image. Pillow is for images. I don't want to create an image. And this is 2D. Till connects points together? You know what? I'm gonna stop doing this because it's not doing anything. Let's just go on Peel. On the documentation. And that's Peel. Wait. Is it Peel? No, this is Matplot, my bad. Oh, okay. That's why I'm finding this stuff. Matplot, lib, 3D segments. plot 0 to 1. Hitotsume no segmento. So from 0, 0, 0 to 1, 1, 1. Do. Okay. I mean, I guess I can do that. So yeah, it just needs, okay. Let's plot at the end. Let's have this in here, probably. So if this is not equal, we plot. So we have the p-index and we have the group, right? So basically this is going to be, well, from, yeah. From pos to pos. Okay, this is making some sounds. My table, I mean, so should be good. So from pos, this is points. The index. Then we have points group. And then we basically have from pos.x to pos.x and this kind of stuff, right? Pretty simple. Not to select, but other than that, this is pretty simple. Z, Y, okay. Let's go. Let's graph that. Yeah, so this is actually working pretty well. I wasn't actually expecting that. But it's still not... Do I have the correct data? I mean, I'm not actually sure because it's like so close. Like each point is so close to each other. So wait, we have... Maybe we just need to connect more points. Oh, maybe it's like NB iterations? Oh. Oh. Oh! Wait. Maybe this is just not... Oh. Oh no. Oh no. Oh no. Oh no. Ah. This is bad. Okay, what if I do the opposite? What if I do this? And instead of doing this, I'm swapping up those. So p-index continues pointing to itself. Yeah, might be good. And then what I do is I equals 10, while I is not 10, actually this is 0. And while this is not 10, then we continue maybe? And I increase here, because I don't know if it's like conditional to here. Because yeah, it was written that we do nothing, right? So maybe what I have is correct, but we just don't have enough lines. This is a, this is a possibility. And now it's looping forever, isn't it? Oh no. Yeah, it's looping forever. Oh wait. Wait, what? Oh wait. Wait. Yeah, this is because I make it point to itself, right? If points to closest. Oh no! Oh no! This is bad. Yeah, that makes sense. I mean, okay. What if I do this? But then instead of doing a +1, I do. Okay, basically, I take what I have. So current connections, NB current connections equals this. This becomes 0, and the target gets increased by NB current connections. Ooh, I'm doing something crazy, but maybe it's going to work. I'm kind of excited. Please. Still nope. Wait, it's actually not even going here. Wait, what? Oh, yeah, of course. Yeah, it's still pointing, well, it's still going on forever. So... IP index, okay. What was it before? Set p index to this. Yeah, sounds good. Then we get the group, and if it's not equal, then we continue. What is I? 1. Oh, this one is... This what? This time it's 1. But what is... sorted points? 19. And 19 is pointing to itself, isn't it? So this is a problem. Yeah, maybe I do need... Okay. Maybe I do need something like NB points. Okay. But I need a counter. So counting, well, current connections equals 0. And we want 10 connections, right? Oh no, I was going to have the same variable name. So connections left, let's say, is 10. Then we do a -1. And if this is equal to 0, then we break, let's say. Let's try again. Okay, now it should be like a lot better because it's going to continue going from point to point. 1, 2, 3, 4. 5. We have 3 and then we have 2. This is it. This is what we want. This is what we want. And this is 30. This is not what we want. Wait, is it? I think this was 40. Shit. So it's 5, 4, and 2. Wait, 5, 4, and 2. Let's check again. Let's check again. But this is actually very close. 5, so 1, 2, 3, 4, 5. Then we have 4. Oh no, we don't have the 4. We don't have the one that is 4 points. Oh no. What if I do this? Let's do that. Please. 1, 2, 3, 1, 2, 3, 5. 15, 45. Yeah, this is not good. And yeah, these are not the closest points. What the heck? What the heck? This is not the closest point. Oh, that was starting so well. Oh no. Oh no. Yeah, what is it doing? Like, why is it connecting the two of those? Maybe set group. Yeah, what if I just comment that? Let's try again. So it's going to be a bit worse, like performance-wise, probably. But yeah. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5. The worst is that this one is correct, this one is fine, but then for some reason there is like this point, Like, why is it connected to? Why are they not like connecting together here? Like, connected there, right? I'm like so close. So close. Let's go to here. So we have the show. I mean, fine. I guess I have to close to continue, right? Can I just not? Well, I guess never mind. Why is this one connected? This one. Crazy. But they're supposed to be correct, right? Find closest naive. Like, this is a naive solution. And this is... Like, I have an assert, so it's supposed to be fine. Square distance. Is it because of the square distance? Am I computing this correctly? Wait, that would be kind of funny if I didn't. X. 1, 1. Wait. I do the minus and then I times that. X, Y, Z, P2, P1. Yeah, I mean, this is correct, right? It looks correct to me. Okay, so what am I actually... I'm displaying each point, right? And it seems to be correct. Axis.scatter. Yeah. And then I am showing each line. Yeah. Okay, there is actually a problem with that. Okay, let's actually do something else. Let's actually, like, for the first 10 points, maybe? Like, 10 for now. Well, let's have this. Correction, okay. Let's have this. From position. I need this one though. Sorted points. So I start at 0. Okay, I increase. Pre-index. I have the points. From 2. Then I can plot. Let's try that. It's not going to be enough, but oh yeah, group. Oh yeah, group. So like this probably. Did I actually do something like that? Group. I guess I'm getting the group. I'm not getting the two. Maybe that's why. Int has no int. Oh right. Yeah, I was actually not displaying the closest. I was displaying the parent, which may have been a bit different. I mean, it probably was. So okay, it looks like that. What? Yeah, okay. What if I increase to 15? Actually, I think it's like taking... Let me check. Oh, it displayed on the other window, on the other display. So this is saying that, oh, this is 20, right? Actually, 20 boxes. 10 shortest connections. Yeah, there are 11 circuits. Okay. Let's not close. So we have this. We have 1, 2, 3, 4, 5. Then you have 1, 2, 3. Then you have 2, 2, 2, 2. What if I increase just a little more? Like 7, 16. And my other question was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So wait, I have the 10 connections right here. I have 10 connections. So this is 5 times 3. 15. Wait. Five, 4, and 2. So wait, we have 11 connections, actually. Right? Where? Where is it? There are 11 circuits. Oh, no, 11 circuits. So 10 shortest connections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I do have 11 circuits. But the problem is, it's not working. I don't have a group of 4. Did I miss like one thing? Looks good to me. Let's check if I close this. Okay. 45. Yeah, really close, but nah. Wait, 40. Yeah, because times 3 times. Wait. 4, 3, 3. No, 5, 3. Okay, this is why. Let's close. I just want to check NB points. 20. So this is, the parsing is correct. The parsing is correct. The find closest is correct. This should be a correct distance, well, squared distance too, as you can see. The sorting, there's no reason it's not correct. Yeah. Yeah. So this is the same as this one, so I can just check this one if I need to understand better, right? So yeah, elimination, this is correct. This is correct. This is 0, 19. It does seem correct to me. Is it? I mean, yeah, there's no reason it's not. Yeah, this is correct. Yeah, it's from smaller to larger, to largest, right? Smallest to largest. Yeah, I suppose it is. Group to size, I do this. So union set. Oh, maybe it was actually fine. But yeah, okay, I do have to wait. Actually, let me restart because so 16. Wait, I mean 5, 4, and 2, right? So why do I have 3 and actually no, I just have 3. I just have 3. 1, 2, 3, 4, 5. 1, 2, 3. So yeah, what about this one now? So you have 2 that are 3 in size, which is like kind of bad. And yeah, this is kind of bad. This is kind of bad. I mean, it really feels like it really feels like this is the problem because it's not the disjoint set because I'm not plotting depending on the disjoint set, right? So disjoint set is used later, right? So this is not a problem with the disjoint set, union set. I'm just plotting points and lines that are supposed to be sorted by distance. Maybe the square distance is a problem? I mean, it's not supposed to be, right? It's supposed to give the same thing. So I really don't think this is a problem, but I'm I'm ready to try everything, anything and everything to see if this works. And it doesn't. This is the same, of course it is. Because it doesn't matter whether it's squared or not. Actually, wait, it was supposed to crash. Oh, no, never mind, because, yeah, okay, I did it with the naive, but there's an asset, right? And the points are ordered in the same way, so I'm just proving that this actually doesn't matter at all. So, if all of that is correct, if the naive, well, if the disjoint union set doesn't matter, then that means the plotting is wrong. The plotting is wrong. Because I'm not using any of that. Or the sort is wrong. I mean, it's possible that the sort is wrong. Wait, is it trying to sort? Oh no. Wait. The order of 2 equal elements is conserved. If a key function is given, apply its once to each list item and sort them, ascending or descending, according to their function values. In descending order. Okay. I really don't get it. So I have 100427. Let's do this. Let's do this. And yeah, this doesn't change. And what changes should be the sorted points, and it does because I verified that beforehand, right? Like, we can see that this is ordered, and then we can see that poof, this has changed, obviously. So the first is still the... I mean, yeah, this is fine. 13 points. I guess we can make a function to verify if each closest point is in the group. I mean, we can actually do that. Like at the end, maybe. Like we have for I in range, NB points. Then we check if P index, well I point, well P index, yeah, equals. Actually no. Let's just have. We have the closest point, right? We get the group of this. Next group. We have, well, this is neighbor. This is a group of the neighbor. So we do that. We get the group of the current point, which is basically the same, but it's just P index that we don't have. So I guess this is just I. Good. And then we assert that this is equal. Right? It should be equal. It's probably going to assert, but that's what I want. Yeah, okay, good. So now we have some idea of the problem. We have some idea. Group is 1 and group is 6. For what? Oh, this is 1. So 1 is pointing to itself. Wait, 1 is pointing to itself? Wait, I mean, does it make sense? Wait, set group. So I set it to the same as this one. Do I? Yeah, I should. That should be it. Right? Yeah. Then I get the group of P index. The group. Yeah, I mean, I could have this asset somewhere else, actually. I mean, let's keep having it, I suppose. But this could be here with group equals a neighbor group, which is, I suppose, this. And that just means that there is a problem here. So, okay, this is actually maybe a problem of what the fuck? Wait, what? Wait, what? Wait, what? Like, really, what? Wait. Am I changing the group of another? Huh? 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 Is it because in get group I'm... Oh. Um... Yeah, but they're supposed to be linked, right? Like the connection is not suddenly going to get lost, right? Oh, if it's set to itself. If it's set to itself. Yeah, but there's no... It doesn't happen. Is it? Does it? And yeah, there's like a problem in the plot itself. So, like, if there's a problem in the plot, then the problem shouldn't be here. The problem shouldn't be here. But at the end, there's still a problem. Wait, this is crazy. Get group. Yeah. Get group of I. Can I print I? Yep. Can I print disjoint union set? Oh. So one is pointing to itself. But wait, it shouldn't, right? Wait, ID to group. Actually, this is... I mean, actually, this is fine, right? It can just point to itself. But then... Oh, because this is only for the first 10. So that's why it's crashing here. That's fine, that's fine. This is only for the first 10 closest distances. And if I check something like sorted points, 1 is probably something very far away. Yeah, it's like towards the end, so that's why. So this is actually correct. And the disjoint set is actually working, that means. Right? Because the assert is kind of alright. Well, I mean, it's normal that the assert is not breaking, right? Because we're doing all of that, but yeah. You can actually optimize it a little, but that's fine. So yeah, the problem is actually there. Like, what? That's crazy. Wait, so this is good. Sorted points, NV points, from 0 to 19. Then we sort. This doesn't matter, this doesn't matter, this doesn't matter, this doesn't matter. And this is wrong, so... This is crazy. Like, really, this is driving me crazy. Let's do this. Or actually even... this. So, yeah, this is... Like, I have even less things before now. So, the sort is probably wrong. Like, I did 2 functions for that. It's not supposed to be wrong. Square this is less than... Then I update. What if this is equal? I guess it's not supposed to be equal, right? I hope. I mean, actually, this is a good... Yeah, never mind. If it's equal, then... Wait. I mean, this is fine. I think. I mean, I can always put this, right? But it's not supposed to change anything, right? Yeah, it's not. So this function is correct. Please. Let's put a breakpoint there. Index. What is index? Oh, yeah, there. So we have closest square distances there. So I guess we can actually... Okay, we can actually check something. So we have this. So we have 0. This is supposed to be the smallest one. And it seems to be the case. The last one is the same. And this is 19. And 19 is second. So this is actually good. This is actually correct. 7, 0, 1, 2, 3, 4, 5, 6, 7. 1, 0, 3. 4, 0, 1. 1, 0, 3. 4, 0. Okay, 1. Okay. Yeah, this is correct. 2, 0, 1, 2. So 1, 0, 3. The others are not. But this one is actually. But then we have 13. So 0, 1. You know what? Let's just make another test for I in range and B points. We assert that actually just actually we start at 1. We assert that sorted points I, and we have sorted point I minus 1. And we just check the distance. And we check that this is less or equal. But yeah, we do have equal distances. So yeah, I don't think it's impacting anything, right? But, huh. Oh yeah, because they're just the same. Wait, this is actually false? Wait, what? 2? Yeah, I guess this is the one I was actually talking about, right? So we have this, 7. We have this, 19. Then 7 is that. 19 is... Oh yeah, wait. Yeah, this should be the opposite. Okay, that makes sense. This should be the opposite. Yeah, okay, this is better now. Okay, let's try again. So this doesn't get triggered. So wait, what am I doing wrong? So is it my logic that is a problem? Because this is correct. This is correct. We have an assert for that. right? This is correct. And then we plot, and it's not showing us what we want. So I mean, am I showing things wrong? I'm just showing the points here. And then there I'm showing sorted points I. Okay. So from the smallest, I get the point, and 2 is p-index closest, points to closest point. Then I get it. I don't understand. Like, everything I checked before should be right, and it's not. I don't have the same results for whatever reason. Do you think these ones are actually closer to each other? Actually, maybe this one is like close, right? Do I need to find some optimized way to increase the size of the tree, maybe? Do you think? Yeah, let's asset that. I'm just thinking about one thing, so I'm going to test it. So either this is not equal, or or what? Can I actually just remove this? Maybe I can't. Or sorted. Yeah. Or this. Oh, okay. Wait. Or the point is equal to this. The closest of the closest. Yeah, let's try this. So this is basically just checking if there are points that are at equal distance. Wait. Oh, this is the distance. Wait, what? Oh yeah, my bad. Yeah, my bad. I just wanted to check the point to closest point, not the distance. Yeah. Let's try again. So the asset is false this time. Okay, so this is actually a big problem. Because that means we might want to search for the case where we have the highest amount of connections. Is it? Is it like saying the maximum or? So yeah, what's actually the thing? Let's check. Wait, this is actually normal. This is not what I wanted to. Yeah, this is not what I wanted to check. This is normal. Okay, this is actually I. Wait, what? Oh. Oh. I points. Okay, yeah, I did something wrong. So let's. I did want to check the distance. If the distance between that and uh, this is not equal, and then if or if that equals that, okay, should be good. Let's try again. Okay, okay, list is not callable. No. And it seems to be fine. Okay, this is fine. So this is actually fine. So okay, my worry just disappeared. So everything should be fine. I like what? I don't understand. Yeah, this is not a problem with the. Actually, I don't know, but but yeah, there's no equality, so it should be fine. 1, 2, 3, 4, 5, and this is correct. That's the crazy part. I do have one thing with 5 connections. 1, 2, 3. Yeah, this one is like really close, right? It's like a bit crazy that it's not connected. I think it should be connected. It's definitely like smaller than some other connections, right? Yeah. Then I put some labeling to Python, matplotlib label to point. That's a plot. Let's have annotate. Axis.annotate, I suppose. A, B. Let's annotate. Scatter. One, two, three, four. I'm scattering lists, I believe. Actually, 3 lists. XYZ. Can I just do the same for? I can probably do the same for annotate. So maybe something like axis.annotate XYZ. And there's actually it's actually the third XY text. Wait. Okay. XYZ. Then what did I want to do actually? Stack Overflow help me. I guess I need the text first, right? Yeah, I need the text first. This is going like to be %s, %s, %s. Like 3 coordinates maybe. Then we have x, y, z. But is it like supporting freely? Oh, text. Oh. Yeah, never mind, because I don't want the coordinates. I just want I. So yeah, this is actually pretty sweet. Like Okay, let's try that. X, Y, Z, I in zip to put everything together. X, oh, shit. I guess this is like X list, right? List, list, list. Z list. Yeah, range, I suppose, for every NB points. So actually, yeah. Then I'm going to axis.text X, Y, Z, I. Actually, just I is enough. So I mean, actually, I don't even need the zip and everything, right? Do I? Actually, no, I need the positions for the coordinates, right? Yeah, I do. Let's run again. So, okay, here we go. Yeah, a lot better. This is going to help us so much. So this one should be good. Now 5. Okay. So if I check, for example, 10. Oh, I guess I want to debug at the same time. Can I guess this is in show. There's like a parameter, right? Or display then return immediately. If true, block and run the GUI main loop. So I mean, if I do false, is it going to stay open? I'm not sure about that, but probably. Shit. Wait, it's block. Okay. Block equal? Wait. Yeah. I guess this is it. This is it. Okay, this is actually working. Wait, what the fuck? Okay. So I didn't think I could interact with it, which is kind of great. So I want to check what's the closest neighbor from 10 is. So let's go there. Let's type point to closest point. And this is number 10 that I wanted to know about. So this is 12. And 12 is like really close, right? And this makes sense, like they are really close. So now let's just get the closest closest square distance of 10. And this is this number, okay? Now let's go to 5, for example. Yeah, 5 is good. 5, closest is 4, which makes sense, they're connected. And what is this? What? This is less. This is less. So 5 and 4 are closer than 10 and 12. I mean, okay, I can see it. What about 6 though? 6 is like so big, right? Yeah, there's no way. Actually, there's a way. Yeah, let's check with 6. So it's 4. Makes sense. Uh, 138, 165. Yeah, this is crazy. How is it so big? Is it really my square dist function that is just bad? That would be very funny. Wait, this is actually possible. No, don't tell me. Oh, this is so bad. Wait. So let's say 10 minus 15. Because I know this is not really how you compute a delta, but let's say this is 2 and this is 5. The distance is 3. But 2 minus 5 is minus 3, and then you multiply, so it doesn't actually matter, right? But now I actually want to make sure. I mean, yes, it is. I mean, yes, the distance is supposed to be correct. 10 minus 15. The absolute is equal to 15 minus 10. That makes sense. X, Z, well, Z, Z, Y, Y. So why is the distance like so crazy? Is it because it's sorted by... Maybe it's actually the wrong distances that are... Wait. This is not the one. This is the one. So this is the max. I mean, none of those are the max, right? I mean, naive is correct. Yeah, the naive version should be correct. And like it's sorted in the same way, so there's no way this is wrong. But maybe the distance is not equal. Oh, if it's not equal to the correct point, then... Oh, actually. I update. Uh, that looks correct to me. But at the same time, like, I have crazy differences. So like 10 and 12. So let's just check. We have 10. All right. We have 12. Then I just compute the square distance. Oh. The square distance between 10 and 12. 2, 1. So yeah, this is correct. This is correct. So if I change, this is supposed to be the same. This is obviously the same. Now what if I do... What if I do... So I was checking with... Well, let me actually look again. With like 4 and 6, right? Like there's no way this is smaller than this. Or maybe it's because of the zoom or I don't know, perspective. Wait. There's no way. was it this? Yeah. I mean, okay, maybe there's a way, but not that much. Not that much. Because that's like so big. This is like the same. So we have 10 and 12 that we just verified. And now we have 4 and 6, right? Six and 4. And this is way less. And this is crazy. This is crazy. So wait, all the points not passed correctly? That will be crazy. Wait, is it? For each line we have this. We have points, X, Y, Z, and we happened. Okay. Okay. So yeah, I guess I can check like 4. I can check 6. And let's check the file. I don't trust any of that. So 4. So this is the one, right? Yeah. 6 is 7. Okay. Okay. So now I'm going to compute it like elsewhere because 5, 4, 2 minus, well, plus 29 plus 2, 3, 6. And now I'm going to do the minus with this 3, 5, 2 plus minus 3, 4, 2. And at the end we have 2, 3, 6 minus 300. Now I power everything by 2. Wait. And what was it supposed to be? Between 4 and 6. Wait, this is not correct. This is close but not correct. Wait, no, 4 and 6, not 5. Okay, this is actually correct. So wait, this is correct? So wait, what about 10 and 12? 4 and 6, 10 and 12. Oh, wait. I don't have a 0. Wait. No, I do have a 0. Okay, so I start at 0, so this is fine. This is correct. I have 10, and I have 12. So let's try to do the same with this one. So this is 216, 146, 977. Go down. 117, 168, 530. And this is correct. That doesn't look like it at all. That's crazy. It doesn't look that big. So what if I square everything? Three, 7, 1. Is it? If I look, yeah, you can say it's like 3, 7, 1, I suppose. Okay, yeah, this is almost two thingies, right? So I guess that's fine. And this one is 458. I guess it might be. Yeah, now that I'm comparing, it might be actually. Yeah, that makes sense actually. So this is actually right. Are you telling me that this is right? One, 6, 8. Okay. Let's go back to this. I want to check another thing. Let's check. Let's check sorted points. 0, 0. Okay, so now if I wait, okay, if I do this is going to be 162, 817, 812, and then the other closest one is closest. Point to closest point, and this one this is correct. 2, 162 and 431. Okay, let's try. So we have this, and we have this. So this is one thing, and this is the second, and maybe they are the same as the first one. So in this case, we don't do anything. Yeah, we don't do anything. So what about what happens next? We have 2, and we have 2. Now they should be different. Yeah, so 162, 817, 812, 431, 825, 988. This is good. I mean, we can continue, just in case, right? Okay, what about these ones? The next two. I don't know if I already checked, but anyways. Do this together. Okay, this is the first one. This was the second one, right? Yeah. So I checked that. They're connecting them. The next two are this and this. This is working. This is actually working. This is actually working normally. Is my plot wrong? No, it's not, because I was still displaying the things. So wait, started point. I start at 0. I check. Well, I get the position. Then I get the closest point. I get the point. And I plot. From 2. Yeah. Yeah. And for some reason I don't have 4. Like, this is not 5, 4, 2. This is 3, 3, 3. So many 3s. What about 18 and 13? Oh, this is a... Okay, maybe I have to check the closest out of the tree. Do I? Wait, do I have to check the closest? Maybe I got the problem wrong. Oh no. Hello! How are you? My headphones are not working today. Can you reply me in chat? Is that a bot? This is definitely a bot. I think that's another ban. Yeah, because I guess what we want is not just the closest neighbor, we want the closest to... I get it now. So the problem is actually even more different than what I thought. Because what I did was correct in, you know. I thought you just had to link to the closest one. But let me read again. Okay. There is a single circuit which contains 2 boxes. 18 remain. Okay. And already connected. Oh yeah. Yeah, I got it wrong. I got the problem wrong. How are you doing? I'm good. What about you? I'm good though, good though. Good. Good. Well, actually, I'm not good. No. Yes, I mean, I get it. I mean, I get it. Okay. Find the closest. I'm also good. Where are you from? I'm obviously from, you know, North Pole, Marsh, something like that, right? Pass input. Okay, let's give it one more try. Okay. Let's give it one more try. So this is correct. The moon. From up there, from above. Okay. How can I actually do it? Nice to meet you. Okay. Sus. I really feel like it's. Do you stream daily? I stream a lot recently. I've been streaming a lot. Can you read on the lips maybe? Yeah, I really feel like that's a scam. But for some reason it's like replying. Maybe ChatGPT? Do you think there are ChatGPT bots just going to comments? That would be crazy. That would be crazy. That would be possible. That internet theory, right? So, yay. Yeah. This is, yeah. Points. So I guess I have to. Yeah. What do I have to do? I guess I have point to group. Still. Um. Uh, Depends. Maybe it's not a bot. Point to group time can be points. Let me focus. So wait. I'm really afraid right now. This is like, I feel like for people that are watching the replay or anything, it's like, you know, some kind of show. I feel like I'm being in some kind of show right now. Can I ask you something? It's gonna be- I feel like he's going to do something like, hey, can you send me money? Hey, can you check my website? Hey, can you come to the US, Texas? Oh, like so many possibilities. Hey, I actually a Nigerian prince in Texas. Can you help me? I just wanna see how it goes. This is such. This is so blatant. This is so shameless. This is so. My God. This is not a bot. Like a bot wouldn't be just. Yeah, the can I ask you something is okay. It's not a bot. Actually, I'm a graphic. Okay, it's a graphic designer. Oh yeah, it's the same kind of people that do that on Discord. Yeah, actually, I had one doing that for Twitch too. Tell me your Discord username. I can show you my work on Discord. And you know, there's like a bot that is just spamming my Discord on Twitch. So I mean, yeah, we got it. It's a ban, right? Wait, I can't. Wait. Accounts create. Wait, I have to show you something, okay? Can I actually detach the chat? Uh, Pop out. Okay, let me show you this. Okay, this is the chat, and look at this. Accounts created 18 minutes ago and followed. But I'm sorry, this is the ban. Here we go. Oh, that's actually kind of sad. Oh no, the comments got removed. But I guess we are going to live on YouTube. Anyway, that was fun. And yeah, welcome, Streamhab. Wait, I don't know. I feel like that's a bot too. Oh, morning. Fine. Have a good day. Again. Wait, that was the other day. What about? Yeah, okay, should be good. Yeah, things are really fun sometimes. Um, Shortest distance. So yeah, okay. I guess I can do something quickly, like for I in range, NB points. J in range, NB points. If I is not J, actually, if it's not in the same group, so we can have points to group 0 times. No, it's actually a range, NB points. We convert that to a list. And if the group is not the same, I'm actually doing the same as before. I mean, yeah, this is basically just the same at this rate. Maybe. Yeah. Yeah, let's have our different union set. I'm glad I divided that in classes and stuff. I have this. I have this dot id to group equals point to group. Makes sense. Actually, this is already being set, so I can just remove that. And now I can basically that gets group of I. If this is not equal to get group of J, then I do the thing. And I try to get the minimum distance like that. So yeah, this is kind of funny actually. Can I? I mean, I guess I can do it the optimized way. Probably. Wait, one to everything. Yeah, okay. So this was find opti. Okay, this is it. So let's actually maybe copy it to have a better ID here. We have the list, which is this, like here. Initialize, point to closest point. So actually now it's like groups. It works with groups, so I have my disjoint union set, so that's fine. Then I compute the squared distance between I and j. This is not changing in any way. And then I can check for both of them. And if this is good, then now I can set it and set group to j from I to j. And this is the same in the opposite way. So from j to I. This is now the same group. And I do that a certain amount of times. So for example, amount equals 10 for k in range amount, like NV iterations. And then every time I have this, now I just have to find the closest distance, which should be... Oh, actually I have to reset it every time, I feel like. Yeah, I have to reset this every iteration to make sure I get the closest. And so this disjoint union set, I guess I should keep the groups, right? Yeah, I should keep the groups. So this should be fine. Let me actually think for a second. I set the groups, but do I really want to set it here? Maybe not. Maybe I just want to set it at the end. Yeah, it would make more sense. So at the end, when I find all of that, basically I'm going to do a find closest connection. Okay. Connection. So I basically have like A and J, okay. And then I'm just going to set to assign both of them to the same group. So I have like actually, yeah, I have to fuse the groups. How do I do that? I just take one and I put it... Oh, wait. Yeah, I take the head of one. And... Okay, no. I'm just going to little break, bathroom. Be right back. Boom. Here we go. And let's just... Actually, maybe I can just keep this music. Yeah, be right back. I'm back. Hello. Here we go. So now I find the closest connection, and basically I set the head to the head of another one. So I guess I have to... What I have to do is like get... get a group of I. But actually, let me make a function. So I have fuse, self, I and j, let's say. And this is just going to get self.getGroup of I, and it's going to set the... Yeah, I'm just going to do this. To the... Well, to j, right? But if I do a set group to j, then it's calling get group, so that's, you know, that's fine. That's what it's doing. So now I should just be able to fuse. I fuse I and j. While I merge. I guess merge is a better word. So here we go. And I and j is like, they're like the closest points, right? So... So I guess I'm just going to do the same as before. But this is not going to be a sort. I just want the maximum element. The maximum, the minimum. So let's just have max dist. Actually, I'm computing so many square distances. Do I really have to? Can I just instead compute everything like only one time? I feel like I'm overkilling it. I'm probably overkilling it. But then if I just get the connections, then I don't have the groups anymore, which is kind of a problem. So, okay, let's keep it this way. So then I have max dist equal this. And, well, actually, can I just get max? No, I can't. Like, math. Anyway, yeah, let's just do that the normal way. So we have the index, let's say. We have... Actually, for I in range, NB points, if if max dist is less, oh, actually it's min dist. If this, yeah, actually this is min square dist. If this is less than this, then I just merge and I break, right? I do the merge here so that I still have the I in the scope, but you know, I know in Python it's not needed, but to be compatible with other languages. So I, and you have the closest, oh no. Okay. I need the closest point. So I guess the closest point is actually going to change. But I mean, it should be fine. So yeah, it should be fine. So closest point. So for I it's J. Yeah, actually we have it right. And same for here, but it's the opposite. Okay. And then then what? Then yeah, I can just get the closest point, and then I can merge, then I break, and then everything's fine. And then at the end, when we have iterated so many times, then I should just be able to do what I did before, which is compute the amount, just compute. Priority queue, do I guess I can. Yeah, let's just copy. Wait, where is my priority queue? Wait. Oh, there. Group to size. Yeah. Okay. Yeah, at the end I just do this stuff. I can remove. I can I? I can remove probably. Not now, but one day. Um, sorted points. Yeah, because I don't really care about that. I just want to count. Group to size. So this is great. Priority queue. Okay. Disjoint union set. Okay. No, not okay. Not okay. Then for every. Yeah, I mean for every point. Yeah, okay. Then for priority queue, that push for every point, I'm pushing the the group basically, right? So this is. Wait, do I have group to size element? No, I don't. So I guess I have the group, which is disjoint union set.get group of I. Now that I have the group, I can increase the size. And now I try to push. I update. So group is this. And that should be fine. That should be fine. It was like a lot faster now that I understood what it was about. Oh no, wrong one. So many ones. Okay, 8. So this is not what I want. I guess I need more debugging, but I guess now I understood the problem correctly. Sorted elements. 0, 1, 2. I mean, wait. Wait. Element to size. So every element is present one time. Yeah, there's definitely a problem. Disjoint union set. Let's. Oh. Oh. Get group. So I'm actually never setting the group. So yeah, I'm actually. I mean, I should be able to go there, right? Why am I even doing that? Wait. That is so stupid. If this is higher than. If this is like that, then I am updating p index equals 0. Then I am updating mean square distance to this. And I am updating p to I. And I am not breaking actually. Yeah, why? Why would I break? P index. Now this is p index. Yeah, this is a lot better this way, right? Okay. Okay, let's try again. So I do have very similar results as what I had before, and now it displays. What does it display? Not fucking 1. It's displaying 1. Group to size. What are you? This is a joke. This is a joke. Gets group. Oh, because this is I. That's not I that I want. Is it? Actually, it might be. Yeah, I think this is actually Y that I want, but that definitely is a problem. Group. Oh yeah, I want to increase the size of the group, right? So yeah, let's do this. $25. I mean, this is getting better though. Is it not? I don't know. Let's breakpoint. And let's check this. 5 and 5. We have two 5s. Wait, this is actually a problem. Probably. Maybe not. Get group. Merge. Uh, It's time for Matplotlib. Okay, we can add for every point. So like there, right? And then we want to show at the end without blocking. So like maybe not at the end, but basically every time we have a new point, right? So let's just put it there. It should be good. And then let's plot every line. So that should be when we merge. We are merging from P index. Oh, so yeah, I guess this is, oh, P, okay. And this is actually what I have. This is nice. And to group? No. To the closest point. Here we go. Let's try. Let's run. Let's see what it gives us. What we get. Int. Yep. You 100% right. Run. Yeah. Perfect timing. So I have this. I have 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. Oh no. I really have too much. So wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is 10, but this should be like 5, 4, 2, I think. If I remember correctly. To give us 20 in total. So something is still wrong. But I guess it's better. I don't know if it's better or not. I think this is probably the way to do it actually. Yeah, I mean the other points are like quite far away. Maybe this one is not supposed to. Yeah, like 2 and 8. I don't know. mean, everything looks nice. Who am I to judge? So, closest point that is not in the group, I and J. This is fine. If this is already in the same group, then we ignore. That's what they said, right? So, square dist. Yeah. I, J. Do I have points to closest point? Do I have to reset that? I don't think I have to, because if I reset the distance, then it's going to update, right? Anyways. And the disjoint union set is just at the end for the merge. It's not changing anything, right? 5 and 5. So this is fine. I guess I can do the I plus 1. For optimization. It's not really necessary, and it should lead to the same. As you can see, this is the exact same thing, but this is like more optimized, right? So I mean, I guess this is it, right? Shit. So yeah, something is wrong when I connect it. I mean, this is just supposed to get like the shortest one that is not in the group. That's like not crazy, right? Yeah, that's like, there's nothing crazy in that. Maybe the get group is... No, the get group is correct, because every time it's like we have 10 connections in total, right? Let's restart. We have 10 connections in total, so that means it's not linking to the same ones again. So that means this is working, the disjoint union set is working. Am I not getting the closest one? Huh. It does seem good. Do we have anything? Five, 4, and 2 that contains 2. Wait, 5, 4, and 2. 5, 4, 2, 2. Wait. 5, 2, 2. So I guess this is a 4. So wait, do I actually... Am I looping too much? Am I looping too much? Is that it? Is that all? One, 2, 3, 4, 5, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. I only have 9 connections though. Wait, I don't understand what he's saying. 10 shortest connections. 11 circuits. One which contains 5. One that contains 4. 2 that contains 2. One that is 5. One that is 4. 1, 2, 3, 4. And 2 that contains 2. This is 9. This is not 10. Wait. Am I crazy? Am I crazy? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9? So wording is funny. Wait, after making the 10 shortest connections. Wait, I feel like I'm in Dora, the adventurer, right? I don't know the English name, but yeah. Like this is, let's count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 10 shortest connections. This is not. Yeah, can you help me understand what it's saying? Because it's like the third time I reinterpret what they're saying, and it's starting to be a bit too much for me. I feel like I'm just going to try maybe with 1000. I actually just want to try with 1000. Let me maybe remove the plotting, like has plot equal false. Let's do this. We keep the variables, so that's fine. But yeah, 1000. Where was it? Oh, iterations. So let's put 1000 minus 1, just in case. Because I feel like there's a minus 1. I'm getting crazy. And then I have input, right? And input should just be that. Let's run it without debugging for, more speed. One of the connection is a duplicate. So 10 connections. Wait, one of the connection. So you do actually do something. Wait, what? Wait. Sorry, ads. That's fine. That's fine. Thank you. Wait. So let's just ignore. Wait. Nothing happens. So wait. Oh, so we bind them together? We connect them together? But we don't increase the amount. Right. I get it. How am I going to do that? Oh no. Okay. So if I mean, so we get the shortest. We merge. I get it now. Yeah, this one is actually for everything here. Okay. And don't worry, Sparkle. Thank you a lot. You're saving me. You're saving me. So yeah, this is the problem. And when we merge, nothing changes. But that means I need multiple connections per point. I mean, I could do a hash map, right? But yeah. I mean that means that means it should actually be better to just make an array of connections in this case. Make an array of connections, then you sort this by distance. Wait. Yeah, every connection, like 1, 1. You sort it by distance. And then what happens? Yeah, my brain is starting to... Shit, it's 3 AM. This is fine. I sort. I sort by distance, and then I can just do it easily, right? And I just have my disjunct union set. But the problem is that how many is it? 1,000? It's like 1 million. Actually, I guess 1 million is fine, but what just happened? Anyway. I guess let's merge. And yeah, this is not the condition. I guess we are going to have an array of connections. I mean, we have to, right? So this is going to be like point to connected points, I guess. I guess this is it. And we are going to do if. Yeah, so that we can prevent like memory-wise certain things, then we are just going to make a function is connected to. We are going to have m, let's say, and n, well, p1 and p naught. Then we are just going to verify p min equals the min between p1 and p2. And I guess we have P max is the maximum, right? So actually, if we want to optimize that, optimize it. Yeah, okay, let's just do that, okay? Then we are going to have, so this is just an array of arrays of nothing times nv points. For every point, then we are just going to get the minimum. And we are going to check if it contains find as, I guess it's the max in this, and we return. And this is a Boolean. And now I can have a function called add connection, or like connect P1 and P2, so we get the minimum and the max to prevent duplicating the arrays. And now I just do this dot append Pmax, and this is it. That should be good. And now our new condition is going to be, I actually wanted to make it anyways, if I is connected to J, well, if it's not, then we do the thing. Oh, not. And at the end, we just connect them, right? P1 and P2. And yeah, that's P index and this one. Okay, should be good now. Please tell me that's good. Tell me this is good enough. So actually, this is actually kind of bad. Let's put back 10. And this is... This is the correct one, right? Yeah, wait. No, test input. Wait, I'm supposed to get 40, right? Not 45. I mean, I guess I can just... Now I have the plot, right? So I mean, I can just do that. Let's breakpoint. Okay, so we have... What the f... 1, 2, 3... What the... Wait, what? What's happening? Wait, this is crazy. Wait, this is like really crazy. Right? This has nothing to do with what I had before. 1, 2. Is it like really the shortest distances? No, I don't feel like... I don't think like they are... I don't know. Yeah. 1, 2, 3, 4, 5. Yeah, like what the fuck? Interesting. If I is not connected to Oh, because it's happening to itself? Is it? Oh no, never mind, it can't happen to itself. So that's great. Now if it's not connected, then we compare. We get everything. We get this. Yeah, let's put a breakpoint there because there's definitely something wrong here, and I have to compare it to yeah. So first is from and to. Um, Here we go. So one, Okay, this is correct so far. This is correct. Okay, this is fine actually. Next one is from and to. Actually, can I just show to pause? Yeah, actually, let me just put that there. It's going to be easier. To pause. Okay, here we go. So first one are na. The second one. Wait. Now the two closest together are this and this. This is actually correct. Wait, okay. Yeah. This and this. This is actually fine. Wait, this is actually correct. Containing 3 junction boxes. Containing 2 and 15. Okay. The next 2 junction boxes are... Let's try. This is totally wrong. Okay, this is like totally wrong. Already in the same circuit. But they were not connected, right? Wait, did I miss something? Let me retry. So 1,6, no. Second is 1,6,2,4,3,1. This is good. Then we have... There's no single circuit. Okay. Next two are 9 and 8. Yeah, this is correct. Next is... Done. Yeah, this is totally different. Okay, so this time we can actually check pretty easily. Yeah, we can like check very easily, which is great. So what's actually the... I guess we have P index. We have P... Well, we have the other closest point, right? This. And now I can square dist, square dist between from pause to pause. Okay, this is it. Now let's check test input. So this is supposed to be this, which is 9. So points 9, and the other one is this, which is 20. Wait, actually I have it up. This is 19. But what about the other one? 7. Yeah, okay, this was 7. And this is 19. What? Points? 2 pause. Yeah, points. So yeah, this is definitely less. So wait, what? What is connected to 7 and 19? They're already connected? Or there? How? Wait. How are they connected? Wait, this is crazy. Why? Oh. Ah. This is the same array. This is a reference to the same array. Ah. Do I actually have to do like this? It is so stupid. Okay, you know what? Let me do something. I in range NV points. I'm going to do it the non-Python way, but this is going to be fine, okay? This way I'm sure that everything should be fine. Here we go. Okay, let's continue. Actually, let me check. 1, 2, 3, 4, 5. 1, 2, 3, 4, and we have another connection. And 1 and... Oh shit! I actually wanted to continue. Okay, this is it. Sorry, did I make things worse? No. This is 20. You finally made me fix it. Thank you a lot. You saved me. I think I'll be able to sleep maybe... Wait, at this rate, maybe 6 hours if I'm lucky. Thank you a lot. You saved me. You saved me so much. Okay. Let's have NB iterations. That is going to be 1000. Let's not run like that. This is very slow. I guess there was better, but I mean... They made me remake it like so many times. I guess there might be a problem if because if I have 1000 connections, then maybe I want to optimize, well, the connections, right? So maybe I actually want to sort them when I connect. And then here I should have like some kind of binary search. Maybe that should help. Well, that would help. Yeah. Wait, why is it taking so long actually? Let's run with the debugger. Wait, this is not even getting here. Wait, why is it even... Wait, it just finished this? Oh. Oh, never mind. There are some numbers. Well, I guess... Wait. Enemy point is 1000. Oh, so there are 1000 points. So wait, it actually didn't matter? $1,000 arrays. Oh my god. I mean, I guess I have to make it, shit. Maybe I have to make a list instead. A list, a set, I mean. Yeah, I just have to make a set. Yeah, actually, this is a better idea. So this is a set now. I could do it with this too, though. But this is fine. Okay, let's redo. Oh no. Dictionary doesn't have append. So let's have what? No. Oh, this is a dictionary. I want a set. So wait. Set dot add. Here we go. I guess a dictionary is, well, a set is going to be even worse than a list for so few elements. Maybe that wasn't a good idea. Shit. 1 million iterations, yeah. When actually 1,000 times 1,000 times 1,000. This is not a good idea. Well, not 1,000, but yeah, a bit less, but this is still not a good idea. Wait, it's actually at 15 already. Wait, let me actually continue. Wait. Oh. 15. Yeah, this is taking so long. My god, 16. This is taking so long. Wait, what's taking so long actually? 1 million should be fast. Yeah, but I'm in Python. Okay, so here we go. So, and then... Okay, so this is instant. This is instant. There is just something in here that is like really slow. I'm even using the square distance though. Oh, that's... Actually, never mind. That's fine. I guess this is really is connected to, right? Because I have like so many... But yeah, now it's supposed to be a Okay. Let me check. Yeah, maybe Python is just really slow, I don't know. Right? Because it's like it's kind of fast, right? It's like instant for me. Almost, right? I guess it's still okay, now it's taking some time. Uh and this is at the end, so that doesn't count. I have the connect. I guess connect and merge might be take. Oh yeah, yeah, of course, yeah. I forgot to update this. Let's try again. This is going to be a lot better now. Yeah, this is going to be a lot faster. A lot. I don't know how much, but I mean, maybe not that much, but still faster. Okay, maybe not. 14. Uh, yeah, maybe I should like, huh? Compute the connections first, like the 1 million connections, and then I don't know. Because yeah, basically I'm doing that. Yeah, I mean, yeah, the problem is that I'm doing that in another loop. So what if for yeah, for every point I should compute the distance to every point. So I could have like a 2D array of 1 million. I mean, oh, also I'm in debug, so I guess this is like a little slower, right? Let me maybe just put uh, if k modulo 5 equals 0, then print k. You know, just to, yeah. Um, let me think a little. Oh, this is actually going to work pretty soon. I mean, we still have to wait like 5 times what we waited so far, but this is fine. Iterations. Yeah, a list was probably better than a set, but yeah. If we pre-compute everything, then we get the... I mean, yeah, if we have like an array of 1 million connections, then we just sort that. And this is more optimized, yeah. Because if at the end I have like a list of dictionaries of sets, then, I mean, yeah. No, wait, that's actually, no, that's 1000 connections. Right, so I don't have to sort 1 million after that. I just have to make 1 million connections. I compute the square distance for 1 million connections, so I don't have to recompute it like that many times. Because right now I'm really computing it way too much. And then I'm just... Yeah, I'm just going through the connections. So yeah, let me actually maybe do that. 1. So I have connections. That is a list of int lot. That was actually what I wanted to do at one point, but yeah. So for I in range, NB points. For J in range, NB points. I'm going to connections dot dot append. This is going to be I, J, and the distance. So square dist between points I and points J. Let's just make sure that we don't have the same combinations 2 times, the same connections 2 times. So we have this. And now for k in range NB iterations, I'm going to have my disjoint union such. This is actually going to finish. I'm so glad I did the print. Okay, so this is the value. Let's verify if this is not the one. Okay, this is the right answer. Okay, let me just go back here and let me just finish this one. So the answer is this. Solution. And now that I have this, what I'm going to do is sort the connections. So we have, okay, in Python, this is lambda x, for example, and we just return the second value, so this is the distance. We sort by the distance, and then I iterate 1000 times, and for 1000 times I connect. So what I do by that is, let's have an I. What I do by that is I have this. I get group, set group. Well, I merge actually. I merge I and the one it is connected to. So wait, it's actually connection equal this I. So now this is connection 0 and connection 1. I merge. Okay, this is fine for that many iterations. So this should be pretty fast, I suppose. And then at the end, I count. Like this. And this should be good. And that should be it. 1, 2, 2. Okay. Okay. Takes no. Really. But yeah, it's going to be a lot faster. Let's try again. And this is it. I got it. I got it. So yeah, this is the same, and this one is optimized. Okay, good. Yeah, so connections were okay. This was actually faster. So yeah, this is actually, well, this is O2, but not really O2. Okay, great. Because, you know, we don't start from 0, right? So it's like kind of off. It's actually ON plus, so at the start it's N, but at the end it's 0, so it's actually N divided by 2. Like the average. So this is 2n, so this is 3n divided by 2. So I mean we remove the... Wait, what? No, this is basically this times this. So yeah, this is n squared divided by 2. Okay. We still divide by 2, but it's still n squared. Anyway, apparently the second ON2 is correct, I think, but n is small. I think, yeah. N2 is correct because you remove the divided by 2. So okay, part 2. The elves were right. They definitely don't have enough extension cables. You need to keep connecting junction boxes together until they're all in one large circuit. One large... Oh. Oh no. Continuing the above example, the first connection, which causes all of the junction boxes to form a single circuit, is between the boxes na and na. Wait. Okay. The elves need to know how far those junction boxes are from the wall, so they can pick the right extension cable. Multiplying the x coordinates of those two. Okay. Continue connecting the closest unconnected. Na. What do you get if you multiply together the x coordinate of the last two junctions? Okay. This is going to be funny. Can I actually just make a function for that? Any points? Yeah, never mind. Let's just have this, which is 2. Yeah, this is going to be pretty fast. I actually don't have any plotting this time. And iteration, this is not needed. So we have that. Connections. Oh, I actually don't even have to merge, right? Because this is just the last one I need, right? What? Wait. Is this really? Oh, this is such a joke. Wait, this is such a joke. Am I wrong? So the x coordinates, so that's like points. and you have, well, x times, oh, I guess it's just, no, never mind, this is good. And yeah, we have 0 though. And wait, this is, yeah, this is good, right? So in the first case, it produces 25272. Let's put that there. 252. Let me just comment that. Boom. So we keep the correct one. Test input. Let's try. We merge. Oh wait, this is actually the last one that is not merged, isn't it? Oh wait, I actually have to be careful about that. What do you get if you multiply together? You need to connect. So yeah, the last ones I need to connect. Oh. Yeah, okay, so it's actually a bit different from what I thought. 176. Yeah. Yeah. Of course it wasn't going to be that simple. Connections. So let's say I have the union set. So I'm going to merge everything, right? I have last connection still, which is going to be something like 0 maybe. And then I guess null could be a possibility. Then for everything inside, oh wait, so I have to stop so that I don't iterate like that many times, like until the end, right? Merge, can merge. Yeah. Wait, what? But yeah. Wait. Oh, right. Wait. Never mind. uh, Wait, is it? No, that's not. I don't really understand what you meant this time. So for every iteration. No. Yes. Gets group 0. I guess I can actually have group to size. Here we go. Sorry, I'm wrong. It needs to be connected together. Yeah. So, group to size. I want to make a while true, but anyway, we have a merge. I think I'm going to do the merge manually. Actually, yeah. So I'm going to have this. Okay. And manual merge. Actually, I can just verify. I can just call the function, probably. This is fine. I just have to check if group. I mean, yeah. So we have P1. We have Peanut. And we want to check group 1 equal this dot get group of P1. P1? Yeah, P1. I guess it's like I and J. Yeah, but we already have an I. Okay, it's P1 and P2 and P0. So you have two different groups, okay? That means if we merge them, so if group 1 is not group 2, I mean, I can actually manually merge. That would like optimize the diskette group, I suppose. This is like kind of stupid. But... yeah, let's just merge. Actually, yeah, okay, no, the set group is fine actually. Set group. So set direct group. Set direct parent, maybe. Direct group, okay, this is fine. I'm just going to call that set dot I from and this. Yeah, should be good. Now I can set the group directly somewhere. This from group 1 to group 2. And it becomes group 1 equal group 2 size. This plus equal group 2 size. So yeah, group 1. And then I just set that to 0 because I consume it. And when this is equal to all of the points, so NB points, I just return so this is going to be 0, but this is going to be, because I have to return something, right? But this is a return, and so I don't need the last connection. Actually, yeah, this is fine. Yeah, this can be a while true. And this is P1 dot x times P nut dot x. This is a, oh no, never mind. Points P1 and points P2. And okay. Oh yeah, that's a while true. That's right. So let's try in debug, probably. Oh, that's a problem. If this is not equal, because I is never increased now. Oh no, I forgot. Plus equal 1. That should be better. That should be a lot better. So what is I? 19. What? That's nothing. Shit. Wait, what? Only that? Wait, that's actually... Wait. Wait, what? Only a length of 190? Oh! Okay, I get it. Okay, I get it. So I guess we still... I mean... Okay, I'm going to keep the 4. Actually, I don't have any reason for that. Well, I don't know the stopping condition, right? So I guess I can keep it. I can keep the I plus equal 1. I can remove this. But actually, no. But yeah, I is less than this. Maybe? Then. And yeah, what's the deal? Group to size. So I guess group to size is just never... Oh. Yeah. Oh, right, because at first it's like 1, right? Yeah, okay, makes sense. Yeah, makes sense. Let's start. Okay. This is not the correct thing. So the correct one is this, okay? So we have let's just put it on the watch list. There we go. Oh, X. I guess X is good enough. Multiply the X coordinates. So this is not at all what we want. We do have a 20 though. We do have a 20. Wait, this actually looks fine. Oh, I know why. I know why. Never mind, I do have the head. I do have the size of the group. So can I just print that? Like print. Okay. So one, okay, so 0 goes there. Then you have 1, 0 that disappears and goes there. Another one, a lot of other ones. 1, 2, 3, 18, 19, 20. Wait. Oh, I guess that's fine, actually. It's like the same reason. Wait, what? 30. Oh, yeah. 12, 8 and 3. 8 and 3. Oh, 8 and 4, yeah. I mean, that looks fine. To me, it looks fine. To me, it looks fine. Get group P1. If this is not... Oh, but I still have to merge it. Wait. Oh. Yeah, oh. Yeah, I mean, that should be fine. I mean, I guess I could compute it again if I really want to. Group to size plus equal to 1. Seven plus 1 equals 8. 8. That looks fine to me. But that's so here, what do I do? I append. I mean, this hasn't changed. Then I group to size. Okay, this is a bit different. Hey, what if I, instead of that, just try the good old way with like this? This is going to take a long time. While what? Connections. Right, we can do that. So it's like 1 million, that's still a lot. I mean, but we did loop like that many times here, right? So I mean, maybe that's not that much actually. We merge, we merge, we merge. And we do G1 equals that. Then we have G2 with this. And if G1 is not G2, then we have like the last, maybe, none. Results. And results equal points. This dot x times that 1, I suppose. And at the end, I return results. Something like that. This is also possible, right? Okay, and this one is 2, 5. Yeah, and this one is the correct. Yeah, I actually think that this is a great way to do things, but I don't know where I'm wrong at. So let me just put an end to this. Let me just put an end. Why is it a flood? Wait, why is it a flood? Oh, right, because of the distances, right. So, okay, that's fine. Let's not put it as a flood, though. Boom. Right answer. Here we go. Finished. Finished on send forward. What's the 9? So I guess I'll have to still catch up. Okay, that looks easy. Okay, this is easy. Maybe. Maybe not. Stars, yay! Yeah, I mean, yeah, if you can see, it's like 4 a.m. for me. And I have like, you know, I still work full time during the day, even though I live stream like during hours and hours during the night. So I just be going, thank you a lot, Sparkly, you saved me, you saved me. I don't know. I think without you I would have just given up. So thank you a lot. Without you I would have been stuck on the first one. I would be like, it's 4 a.m. I haven't finished the first one. I'm going to quit. I'm going to stop this one. And I'm going to go to the next day instead. But thanks to you, I finished it. Thank you a lot for that. Thank you a lot. And yeah, I'm still a bit curious about why this is not working. But I mean, I guess that's it, right? But you can save a bit by not computing. Yeah, that's what I'm doing. I'm already doing that. That's why it's called square dist, right? I've actually been doing that since the beginning. But But yeah. But it wasn't working. That's the difference. And it group. P1, P2. Yeah. If this is not equal, maybe I need to merge even if this is equal. That's what I was thinking, but I mean, it should still be the same, right? Like whether it's equal or not. Maybe. Let me actually just input. Yeah, I don't want to stop. I don't want to stop. One. Okay. Then you have this. Let's not do this actually. Let's just merge directly. And instead, this is going to be results. This. Then I just break, I suppose. I plus equal 1, so let's just I in range. So this is a bit more clean, right? A lot more clean. Yeah, let's try again. I want to see if I remove the if. Well, what it does. None. Oh. Oh. I see it now. Wait. Uh-oh. What? Why is it none? Because it's reaching the end, but it's never... Wait, that's crazy. Oh no. Wait, it's supposed to start at 1. Oh, but since it's the same... yeah, that makes sense. It's trying to merge, so... So yeah, if group 1 is not group 2... Oh, actually, maybe it's because of the groups. Because I'm merging... What am I merging? I'm merging the parents, right? I mean, yeah, no, that's fine. I don't really see the problem. Set direct group. Group 1 to group 2. So wait. From and to. So I guess this is now the new parent. So I guess it's group 2 who should get this. Yeah, that looks good to me. Looks good to me. Oh, wait, actually, is it the one before? Wait. Did I actually close the advent of code? Oh no. Not this one. Until they're all in the same circuit. The last two junctions. So I mean, yeah, I don't see the problem with that. I mean, the only problem is equal 0, right? So I guess I have group 1 size equal this. Group 1 size. And then I remove group 1 size. This is not supposed to change a lot, but, you know, well, I don't. Wait, this is actually working. I did it. I did it. I did it. Okay, now I just... Okay. Now, I just want to see that. What's the duration? Without the print though. So without debugging. This is this. And what about this? 1, 2, 3. Okay, this one is actually faster than this one. That is crazy. That is crazy. I mean, my optimized solution was supposed to be optimized, but it's actually not. That's so sad. Because I guess I have an additional buffer. I guess this is like, there are less conditions. Oh wait, this is different now. Wait, this one is now slower. Wait. I guess it depends on... Can I take the precision? Python time precision. Oh no. Time it. Oh, time dot. Well, time ns, nanoseconds. Yeah. Let's try that. And let's actually... I guess I actually want to compute it after parsing. Or maybe I actually want to compute this directly. Thought. And print. Because I don't want the input output. Yeah, I guess I just want this part, right? Thoughts. Okay, let's try it. What a joke. Wait, this is 0 in nanoseconds? What a joke. What a joke. Test input. Oh, okay. Yeah, this is not input. Let's try again. Okay, now this is a lot better. So this is the duration. What about if I do this? Let's go. This is so optimized. This is so optimized. Okay. Okay, yeah, this is really optimized. Okay, I'm so glad I managed to make it work because I know I have the complete thing. I have the complete thing. I guess the only problem is like the first one is kind of ugly because of the connections thing, but actually no, there's no... Yeah, actually, oh. Okay, this is actually pretty good then. So, optimize well, break on last merge. Let's say this is a ball. And if we don't want to break on the last merge, we do that. else we do that. And here it is. Here it is. And this is so optimized. So this is nanoseconds. And this is like this nanoseconds. And this is it. Thank you again, Sparkly. Thank you a lot. And let's check if we have... Yeah, we have some people doing the Advent of God today too. So here we go. Thanks, Palm. Actually, that's me. Wait. Wait, so there's Advent of God. Is that... Yeah, that's two different guys, and there's me just face palming. This is like... I actually want to take a screenshot. Wait, 2 seconds. The music just stopped for some reason. But don't worry, I'll be here. And I mean, we're just finishing the stream, right? So I mean, we have this one, or we have this one. I think I rated both of them already.
昨日
Oh,
す
there's
ごい
another.
ツッ
Oh,
コミを見た。
ツッコミを見た。何ですか？今まで見たことない何か
So I wonder
なんだろう
which
か。
the first one would be that it didn't have. I should actually
That's not AOC, wait.
skip all of them and just write the one that works.
Oh, so many
So I
AOCs!
should just
Oh shit.
do the one that says, okay,
What the?
it's match.
That's like
So
some
I'm going to
crazy
do
guy.
if match.
If match. Manifestando. Yeah, he's using his own language, right?
Something like that.
Yeah, actually, I'm not sure if I rated this guy. Yeah, let's raid.
I can just do
I mean,
this. So if I stop this again.
yeah, let's go.
And I just write out the ones that are matching. Let's see, looking at the shape, the solution would be P1 times
Thank you again a lot.
minus 2, and the 2 is the width.
Thank you a lot, Sparkly. Thank you to the bots who added like some views, I suppose. With that, I don't know.
Is there something wrong?
And
let me just delete
see you next time.
The real ones.
Boom.
So we generated 640 images. Sure.